Okay, so when we're dealing with complex numbers, we may ask you to divide them, or we might ask you to find the square roots of them. So, first one, let's calculate 3 plus 4i divided by 3 plus 2i. Okay, so what we're going to do here to help us is we're going to use the complex conjugate and we're going to use that to make the denominator real. Okay, so we use that to get rid of our imaginary part on the bottom, because when we're looking at this question, what we're really saying there is 3 plus 4i over 3 plus 2i. Okay, and more often than not, we are going to find that the bit causing us a problem is that imaginary part there on the bottom. Okay, we don't like that. So just like when we're asking you to rationalise the denominator with surds, okay, that's essentially what we're looking to do here. So we've got 3 plus 4i on the top over 3 plus 2i on the bottom. And so we're going to multiply top and bottom by the conjugate of the bottom. So if it's 3 plus 2i in the bottom, we need to multiply it by 3 minus 2i. I'm going to do the same thing to the top. That is going to give me 3 plus 4i at the top. 3 times 3 minus 2i, all over. And we're thinking back to our shortcut from the other video. If we take our complex number z, multiply it by its conjugate, and we've got z bar is equal to a squared plus b squared. And so what I can do is I can jump straight in and say whatever's in the bottom is going to be 3 squared plus 2 squared. Multiplying out my top bit and tidying it up, I'm going to get 17 plus 6i all over 3 squared is 9 plus 2 squared is 4, and that gives me 13. Okay, and from that we can start to try and tidy up. What we're really doing here is that is enough, okay, to kind of hammer our point home. Instead, if we really wanted to nail it down, we could have it as 17 over 13 plus 6 over 13i. And what we're doing is we're just trying to get used to the fact that we can split the fraction up into each of the parts. Next one, what we again seem to like to ask you to do every so often is we ask you the square root of 3 plus 4i. So what we're going to do is we're going to let a plus bi be equal to the square root of 3 plus 4i. Okay, and again we're remembering a and b are real numbers here. What I'm going to do now is I'm going to square both sides. So I've got a plus bi squared is going to equal 3 plus 4i. If I multiply this out, I'm going to get a squared minus b squared plus 2ab, and that is still equal to 3 plus 4i. What I'm going to do is I'm going to split it into its parts, and so I've got my real parts. Okay, I've got a squared minus b squared on this side. Let's use a colour. I've got a squared minus b squared on that side, and my real parts on that side are 3. So they there need to be equal to 3. And a different colour, let's go for a yellowy one. And I've got my imaginary parts here. 2ab needs to be equal to 4 on the other side. And so then I've got my imaginary parts. 2ab is equal to 4. That gives me an equation 1, equation 2. So what I can do is I can rearrange my second equation. So a is going to be equal to 4 over 2b, or if we like, just 2 over b. And I'm going to sub that back in to the first equation. Okay, so I'm going to end up, so I'm subbing 2 over b in for a, and so I end up getting 4 over b squared minus b squared equals 3. If I multiply through by b squared, I'm going to get 4 minus b to the 4 equals 3b squared. And I'm going to take everything over onto the one side so that it's b to the 4 plus 3b squared minus 4 equals 0. I can factorise that. And so that is going to get me b squared plus 4 times b squared to the minus 1 equals 0. Now, we said right at the very start that a and b had to be real numbers. So b squared plus 4 is redundant here. Okay, if I try and solve my b squared plus 4 equals 0, I'm going to end up getting b squared equals minus 4, and then I'm going to do the square root, and so I'm going to end up getting b equals plus or minus 2i, and that's not a real number. Okay, it's a complex number, and so we can rule out that first one, and so the b squared minus 1 has to be the thing that we're interested here. Okay, so b has to be 1. So, as b is equal to 1, how can we go from here? Well, we know what a is. A is equal to 2 over b. So 2 over 1, which is just 2. Okay, that's not our only answer though, because remember, just like we did here, we had plus or minus I. If we did b squared equals 1, b is going to be the square root of 1, which is plus or minus 1. And again, that's going to be the step that's going to cause us the problem. Most of us are going to get this first bit. Right? The thing that's going to cause us the issue is going to be the next part. So we need to make sure that we remember and include it. So we've got our first value for b equals 1. Next one then, if b is equal to minus 1, a is equal to 2 over minus 1, which equals minus 2. Okay, so my solution, let's scroll up a wee bit, is going to be z equals 2 plus I, and another one z equals minus 2 minus I. Okay, so again, remember it was taking the form z equals a plus bi, so all I've done is I've substituted a and b into this for each of my set of values. I've got one set there, a second set there.